are the electrons? Quantum numbers are numbers that will help describe where they are. It's like a zip code. Like our zip code is 91915 at Eastlake High School. Tells us what state and that we're in Chula Vista, specifically in Eastlake. Here, quantum numbers are numbers that tell us approximately where the electrons are. And there are 1, 2, 3, 4 quantum numbers. For now, I won't tell you what the numbers are. I will just describe them to you. Okay? The principal quantum number is nothing more than the energy level. And the symbol for energy level is N. Sometimes they're called shells. Okay, so if I say that it's in the first energy level, then N is equal to 1. If I say that the electron is in the second energy level, N equals to 2, that means it's a little bit farther away from the nucleus, and so on and so forth. Pretty simple to understand. Okay, now within each energy level, you can have something called a sublevel or subshell. Subshell, sublevel. You can think of it as, let's say the electron lives in the first floor of a building, and the subshell would be the kind of room they're in at that floor. Okay, so that's called the angular momentum quantum number, and it's nothing more than the subshell or sublevel. The symbol is lowercase l. Okay, so the subshells or sublevels are also sometimes called the orbital type or orbital shape. Okay, there are these orbital types. The first one is called the s orbital. The s orbitals look like this. It's just an area in space. If this were the y, the x, the z, and the z, the y, and the x-axis, then the s orbital would just be a sphere where the nucleus is in the middle, so the electron is somewhere in there. Okay? If that one's filled up, then the electron can go into a p orbital, and these are the p orbitals. There are 3 p orbitals. Okay? So it could be a p orbital. Okay? So let me just list them to you. They could be a p orbital, look like dumbbells. The d orbital, they look like these flowers, and then the f orbital. Okay, so if the s orbital is filled in, you can put them into a p orbital. So that's the x, y, z, and there are 3 different p orbitals. One of them could be on a lobe on top or the bottom of the nucleus on the z-axis, to the left or to the right of the nucleus, or the electron could be in front or behind the nucleus. So there could be 3 possibilities where the electrons may be. So I will put a box here that signifies 1 orbital, and then I will put a box here, 3 boxes, that signifies 3 orbitals on the p sublevel. Okay, so this is the p level. Now the d, if that one's filled up, you can go into the d orbitals, which there are 5 of them. Okay, so it would be, I'm just going to draw an odd flower. I don't really know how to draw them. And this one is in the, whatever, part of the axis. It's just the way they're rotated in space. So this one is rotated up and down, and then these ones are rotated on the ZY plane. It doesn't matter. It doesn't matter, as long as you know that there are 5 orbitals in the d sublevel. One, 2, 3, 4, 5. I'm not even drawing them. And then if that's filled up, they can go in the f sublevel, and it looks like these. And there are 1, 2, 3, 4, 5, 6, and 7. 7 squares. 1, 2, 3, 4, 5, 6, and 7. Okay? So these right here, the different orientations in space, like this one, if you move it in the X, Y, Z plane, it's the same volume in space. Here, if you move it in the Z, it's in one area, and then over here, it can be a different area in space. So this is I call this like the orientation in space. Is it on the XY plane? Is it on the XZ plane? Okay. Okay, so let's practice again. So let's say if the electron is in the first energy level, I say n equals to 1. If it's in the second, you say n equals to 2. If it's in the S sublevel, you say it's in the S sublevel. If you say it's in the first orbital there, it's in the first box. Okay, if I say it's in the third energy level, then you say, okay, 3 spaces away from the nucleus. If I say it's in the P sublevel, it could be any one of these. I can say it's on the Z plane. It could be in this orbital right here. Okay, so each orbital, so just for terminology wise, each square is called an orbital. An orbital. Okay, and then all the 3 squares is called the P sublevel. Okay, so this is a d orbital, and all of them is called a what? It's called a d sublevel. And this is an f orbital, and all of these are called all of them are called the f sublevel. Okay, so each box, okay, each of these orbitals can fit 2 electrons. Okay, so you can fit 2 in here, 2 electrons here, 2 electrons here, 2 electrons here, 2 in each orbital, any orbital. It can be a d orbital, it can be an f orbital. You can fit 2. 2, 2, 2, 2, 2. Okay, so in the S sublevel, which is all of this, you can fit up to 2 electrons total. So that exponent is the number of electrons in that sublevel. Okay, electrons in the S sublevel. So how many electrons can you fit in the P sublevel? 2, 4, 6. In the D sublevel, 3, 4, 6, 8, 10. And then 7 orbitals times 2 is 14. That's how many you can fit inside it. So you can fit up to 14 electrons in the F sublevel, but you can only fit 2 electrons in the F orbital. Okay. Okay. So let me just test you. In the F orbital, in an F orbital, how many electrons can you fit? You can fit 2 electrons in any orbital. How about the F sublevel? How many can you fit? You can fit all of those, 14 electrons in the F sublevel. Okay, so let's practice. I'm an electron, I'm in the 3rd energy level, so I'm 3 levels up, far from the nucleus. I'm in the D sublevel, so I could be anywhere in any of these orbitals. You don't know which one. I'm just saying I'm in the first one, so then it's more specific, right? So it's kind of like you're becoming more and more specific as you go to the right. Okay, so the symbol for this one we're not using right now is M sub L. It's called magnetic. M for the magnetic quantum number because it's moving in space, X, Y, Z, and then L because it's based on this sublevel SPDF. Okay, another thing is the pattern. This is 1 square, 3, and then you add 2 more squares, that's 5, and you add 2 more squares, that's 7. The next one is going to be alphabetical, so it's G, H, I, right? So the next one will have, you add 2 more squares, that's 9, 2 electrons each. No. 5, 7, 9 times 2 is 18 electrons, and so on. As you notice, you're increasing by 4 electrons every time. Okay, pause the video and just try to understand that, please, and write this down in your notes. The last quantum number doesn't really tell us where it is, but it tells us the behavior of the electron. It's saying that the electron spins. And when I say spin, you are the electron and you're spinning on your axis, like spinning like this or the other way, or like this or like this, okay? Like a top, okay? So the way they found this is because if you had a hydrogen atom, it has a proton and an electron, that's hydrogen, and let's say you have 2 of them. And you send this through, and there's a magnet on the top, let's say right here. Do you think these hydrogen atoms will go straight or get deflected? Okay, you think they'd go straight because they're neutral, right? But no, some of them went that way, and half of them went the other way. And the reason that happens is because this electron right here is spinning one direction, while this electron is spinning the other direction. The electron is spinning. So the electron is spinning one direction, and the electron can also spin the other direction. Okay, so the way we signify that spin, this is called the spin quantum number, and the symbol is m sub s, is this one is going to be an up arrow with just one line to the left, just to make it like more efficient. And then this one will be a down arrow. It doesn't matter which is which, just know that one spin and the other spins the other way. So the way we draw it sometimes is you'll see people putting into the sphere, let's say if you're in the 1s orbital, they'll put an arrow that, like 2 arrows, 1, 2. That means you can fit 2 in there. You can fit 2 in here. You can fit 2 in there. And remember, the electron doesn't have to be on one side or the other. It's in there somewhere. Remember, it's a probability or density mass calculation. So in here somewhere, 2 in there, 2 in there, 2 in there, and so on and so forth. 2 in each area in space. Okay, 2, 2. Okay,